Hello, my name is Roy Chi, and this is my poster on identifying micro-urban air quality patterns using cost-effective sensors. So first, onto the background. First, it's important to understand that air quality is a very serious matter in Hong Kong. Many factors like gas vehicles, its proximity to industrial sectors, shipping boats have caused Hong Kong's air quality to be a serious concern to its population of over 7 million. We can see from IQAir's annual PM 2.5 concentration levels, Hong Kong has consistently been rated 3 to 5 times the HOW's air quality guidelines. And in 2024, we can see that concentration levels of certain pollutants exceeded the HOW's AQ guidelines by at least 61% and at the most 550%. This is a concern because air pollution can be extremely detrimental to a person's health, especially in the long run. It can cause chronic obstructive pulmonary disease, lung cancer, and can increase the chance of stroke. And studies have shown that even in short-term exposure, elevated levels of air pollution increase the rate of heart attacks only hours after exposure. Specifically in Hong Kong, an estimated 3,500 premature deaths resulted from air pollution, and $42 billion in Hong Kong economic damages were caused by air pollution. Obviously, it's extremely important for the citizens of Hong Kong to keep track of pollution, so that if they were ever exposed to pollution, they can move to somewhere with less of it. So what can we do about it? So there have been regional air monitor trackers being placed across Hong Kong, but these air quality monitors face one major weakness. They're unable to track changes in local air pollution that result from specific activity. One study in 2021 in Taiwan found that activities of night markets increased the PM 2.5 levels in that very small local area by 1.6 times the regular level. If only regional air monitors were used to measure pollution levels, then people would not be warned about the dangerous pollution levels in those small areas. Thus, it could be beneficial for there to be a low-cost air quality monitor to be deployed en masse to measure local levels of air pollutants and warn people of the local levels of air pollutants are too high, so they may move somewhere else. The methodology. So, the first step in methodology is to identify locations of varying urbanness. Choice of location is important because, well, first, it could help identify which types of areas need to be measured. And, for example, if a certain type of area could never fluctuated, then we could possibly avoid measuring those types of areas if these air quality monitors were to be deployed. Then, once I found those areas, I found a suitable indoor and outdoor placement for them. And then I would install it, record indoor and outdoor pollution levels for one day, identify the spikes, and observe the trends. And I would use that to show how the increased level of pollutants in those micro areas show the necessity for micro level monitoring. So the locations, 3 locations were chosen based on the varying characteristics. First location was on the roadside of Wan Chai, which is right here. This location was chosen for its proximity to traffic and to the city center. It could be the benchmark for an air quality sensor that is in a packed urban city. The second location was in Parkview, which right here, the blue dot. It could be a benchmark for a less urban and more environmental place, as it is located in the middle of a country park. The third location is Up Lake Chau. It's an island off the southwestern coast of Hong Kong, and it's an area with regular but minimal traffic, but it does have a lot of maritime traffic that goes through the channel. That is this yellow circle, yellow star. And onto the measured pollutants. The measured pollutants were CO2, O3, and PM 2.5 and PM 10. You can see the sensors I used here. And these pollutants were measured because in high concentrations, these pollutants are some of the most harmful to the human body, even in exposure to the short term. And while some of these measured the pollutants relatively, the PM2.5 and PM10 sensor measured PM levels absolutely. So after I did all of the data gathering, here are the results. See, the air quality monitor managed to capture fluctuations in air quality at all locations. You can see in this graph how for the graph of PM 2.5 concentrations over a day outside, there are 2 instances of spikes rising above unacceptable levels. You can see in Wanchai outside, it rose to about 80 micrograms per cubic meter, and in Wanchai, it rose to around about 30 micrograms per cubic meters for more than an hour. And these spikes weren't recorded by regional air monitors on the day that this happened. So people were not warned about the potential dangers they were facing. You can also see in ozone here and in CO2, there are spikes. Here CO2 rose by 4,000 ppms for over 6 hours. And here O3 deviated or spiked up from its base level by around about 40 micrograms per cubic meter, and that happened for about a few hours. And this is dangerous because those increases could put the air quality level to a dangerous level, especially for longer than 6 hours. Here also CO rising by around about 40 micrograms per cubic meter for around about 6 hours, which is also very dangerous short-term. And none of these spikes were recorded by regional air quality monitors. So it is very important to have these types of local air quality monitors for measuring these local changes. So the conclusions we could pull from this are: number one, as expected, we could pull that the hourly Hong Kong AQHI index, which is the regional hourly air quality monitors, it failed to pick up the same spikes. So, and during these periods of high concentrations where we saw the spikes on the air quality monitor, people could have been warned to move to an area with less pollutant concentration. We also found that, expectedly, places closer to city centers, more urban, tended to have bigger spikes in pollution, fluctuated more. Outside areas tended to vary a lot more than inside areas. And just as I said, PM 2.5 levels rose to unsafe levels twice. In an indoor instance, CO2 levels increased by 4,000 ppms. People in these areas should have been notified of these elevated levels. But there are some limitations to these results. Data was collected in 24-hour timeframes, which means a larger time frame could possibly lead to discoveries of different patterns. Another limitation is that the data collection was not synchronous. It was not simultaneous. It's possible that some days just had worse air quality and pollution than others. Third limitation is the accuracy of the sensors. Since I'm using low-cost sensors, they aren't extremely accurate. And a fourth limitation is the size of the environments. And because the environments are super small, the limited and the sample size is very limited, extrapolation to other environments could be inaccurate. Yep, that is my poster. Thank you for listening.